morning, everyone. I'm Catalin Ciobanu, CTO at Boost.rs. It's my pleasure today to tell you about data mining, which is one of my favorite things in the world. So we have 90 minutes together. I would say that's plenty of time. So if at any point you have questions, can everybody hear me okay? I can hear me in my head a little bit. Yeah, so if you have any questions at any point, just ask them. Don't hold them to the end because 90 minutes is a long time, and I'm afraid you're going to forget them. So as soon as you have a question, go ahead and ask. We have plenty of time. Make sense? Yeah? Okay. So let's see how we go here. So a bit about me. I guess I'm at my third life right now. The first one, I was a physicist, a high-energy physicist. I work at CERN. I work at Fermilab, more at Fermilab than at CERN. I guess if you're familiar with the 10,000-hour rule, I put probably more than 10,000 hours in just pure data science. Doesn't mean that I'm good, but at least the necessary condition I have it. Then I moved to industry, in the travel industry. So I worked for 7 years in a large corporation, so I know a bit the dynamics between data and corporation, everything in the corporate ecosystem. And then for 2 years, I've been an entrepreneur. Boost.rs is a company that's neither in science, neither in the travel industry. It's in the talent management sector. So we try to help people figure out where they want to go and how to get there. Okay, so without further ado, I wanted to start a bit with talking about success. I think it's important when we talk about data mining to take a moment and say, if things work perfectly, where would we be? Where would your organization be? I think a story of success is for sure Google. 110 billion in revenue, that's not a small thing. Market cap is probably over 700 billion. I didn't check, probably they didn't get to 1 trillion yet, but they're on their way. If I look in other domains, so perhaps you can come in the front, if that's okay. There's a few places here. And no worries, you did not miss anything yet. Okay. So moving out to other fields, the CERN, the God particle discovery, if anybody knows what that is? One person. So apparently that's not that big, but okay, it's kind of a big deal. So they find what's called the Higgs boson, and the Higgs boson was kind of the last missing particle that was anticipated of the standard model. So that was kind of cool. Then, depending on which side of the political spectrum you're placed, you can look at the re-election of Obama in 2012 as a analytics success, data mining success, or the last election as a success. They both use, I would say, heavily, data mining, analytics, and all those tools and processes. Okay, so that's with the success in mind, but we're talking about data mining. Maybe I should have started with what's data mining? What do you understand by data mining? I'm going to try to define everything just so we make sure you know that you're the right workshop, so to speak. So, what's any volunteer for what's data mining for you? Okay. Does it have to be large, the amount of data? Depending on how good the pattern. Okay. Okay, so I actually had the same kind of answer here. So it's using data analysis to extract, instead of patterns, I use insight, kind of the same thing, maybe. From data, yeah. I just said from data, not from large amounts of data. So that's, otherwise, I think we're in sync. You're at the right workshop, at least. Okay, so what is data analysis? Because we say using data analysis to extract insight. Well, what is data analysis? And this is as far as it goes, my craziness with the equation and anything. So data analysis is solving a problem. And solving a problem is you have a bunch of outputs, an input. So there's some input, there's a situation, and the question is asked. And you're supposed to use that input to solve that question. So to create an output to that problem. That output is your solution, right? So it's as simple as that. So data analysis is finding that function, that way in which you link the input to create an output. That's that. Now, what is insight? Since we said, okay, use data analysis to extract insight, and I'm just going to move over here. So let's see if that works. Yeah. So I jumped one. Well, perhaps, yeah. Okay, let's do that first. So this is my classification of problems that we encounter. So, and I'm saying you encounter in business. I think in every walk of life, they're kind of the same thing. Type 1, it's the simplest one, which is clear input, clear output. So depending on, remember, the function was linking input to output. So type 1 would be if I ask, what is the average age of everybody here, right? Okay, it's clear what I'm asking for. I'm asking for a number, average age, number of years. Clear input, yes, it's clear. Everybody's in the room, and I can kind of see a way to do that. Well, I'm just going to ask everybody, and I'm going to, sum and divide, and that's clear, and I'm done. Type 2, as soon as things start being unclear, it starts to be difficult. So type 2 would be unclear input, clear output. Now, that's a different beast. It's a different beast. So that one would be if you've ever done an interview where they say, some things that come to mind, it's how many golf balls are hit in Chicago every weekend, for example. Or let's see another one. Okay, they give you some switches and you have to turn on and figure out if the light is on in the room or off or some stuff like that, or which one turns the light on, whatever. So in those cases, can you still hear me? Sorry, I touched my. Okay, in those cases, having the output clear, it's a good thing, right? You might not know how to solve it, but you have at least, you have the light is at the end of the tunnel, right? Let's try to do just one or two. It's not data mining, but it's important to have that in mind, that classification in mind. So let's ask something about like Cluj. How many, so anybody has a question about Cluj that we can try to estimate like that, but it has to be a clear output. How many manhole covers? Manhole covers are in Cluj. All right. So how do we estimate how many manhole covers are in Cluj? Who wants to take a shot at that? Three. All right, very good. So I would have said 0 or 1. For me, when the answer was like somebody else, I would say 0 or 1. So we have 0, 1, and 3. No, seriously. So the way the manhole cover, so that one, probably one way I would go about estimating, I would say, okay, how many streets are altogether in Cluj? From the plane, it seemed to be like, I don't know, 6 by 6 kilometers, town, so that's 36 times, I'm going to say 36 square kilometers. Per square kilometers, I'm going to make stuff up. Let's say, and again, it's purely made up. Let's see. Let's try to get this one a bit right. So for 1 kilometer, that accommodates about 10 streets, like parallel streets like that. Again, made up. Within each of these, let's say in a kilometer, I'm going to have, again, maybe they're every 100 meters. So in fact, let's say it's 10 by, we said 10, yeah, 10 by 10. So it's 100 of them, right? So let's say it's times 100. And there you go. Do I feel good about this? No, it's probably underestimated. But the thing is, for a type 2 problem, try to get always the first order answer. Right? So I know that the order of magnitude is okay. It's probably within the 10,000, right? Between 1,000 and 10,000. Maybe it's more. Maybe I'm surprised this is more. but that's a good thing. Then if you have time, so if I had now 15 more minutes to talk about manhole covers in Cluj, I would start saying, well, the streets are not really like that, and they're like that, and maybe there's some manhole covers in people's whatever houses, and how many houses, and all that. So that's called the first. So the first order is this. Second order is I'm going to try to correct that for those factors that I did not consider. And then what do I consider? Cluj is the postal code, is the suburbs, is whatever, and then arrive to second, third, fourth. So the thing to remember here, as opposed to the first one, maybe in a type 2 problem, you'll never get it right, never. Well, to get it, or you will get it right if you go to the town hall and ask exactly for the number of manhole covers. But otherwise, you won't get that right, and that's fine. That's fine. So you go to successive approximation, you'll pass your interview, you get hired, and it's all good. Type 3. Type 3 is the worst, so to speak. So as soon as the output is unclear, you're done, because obviously the input is not going to be clear. If the output is not clear, that's not done. So this would be your CEO, or sorry, if you're the CEO already, your investors or whatever. It would be your CEO asking, hey, can you have a look at reducing drop-off rate? Or can you look at what we can do to increase the signals or to make this quicker, right? So when they say, can you take a look, it's a type 3 problem, right? Remember that. Immediately okay, that's a type 3 problem. So, and unfortunately, those are the ones we deal with every day, right? There's rarely that people say, well, give me exactly the number of manhole, whatever. They would say, well, figure out how to do this and that. And data mining is probably, I would say, it's more here and a little bit there, right? So it's not that I'm completely crazy going with manhole covers, but you have to understand where you want to use data mining. There's no point in using data mines for the first one. There's nothing to mine about. If the question, I mean, that's the question we get in schools, right? So in school, that's the exams we're taking. Okay, you're given a bunch of input and you're asked to produce a node. Am I making sense so far? Or I'm talking a lot, but I forgot to check. Does it make sense what I'm saying? You recognize the type 3 dealing? Yeah? Yes? No? Moving on? Okay. Well, we can go here. So what is insight, since we started to talk about that? So what is insight? Who volunteers?
Knowledge on the subject matter.
Is what?
Knowledge on the subject matter.
Knowledge on the subject matter. Okay, what is knowledge?
Information.
Okay. So what's the difference between insight and information? So on one side you say, I'm going to give you some information. On another one you tell somebody, I'm going to give you an insight. What's the difference between the two?
The access level. They have access to something that's not more pinpoint than information. That information is strict. Insight is actionable.
Insight is actionable. So there's something about insight is actionable. So I think all of those are right. So insight is actionable, meaning that insight is, by saying insight is actionable, you're saying information is not, pure data is not. So there's a difference between information and insight, and the fact that one of them is the result of analysis. So I've done some analysis using that information, I got to something else, which I call insight, right? So by my definition, which probably is the same as that, and this is just to show you an example of insight, just to know it when you see it. That's the analysis I done when I was back in the travel industry. So, well, I'd let you 10 seconds to look at this, and I'm going to try to see if we get what the insight is here. All good? So what's somebody more from the back to make sure everybody's following? So what's the insight? What's the first insight? What's one insight in this visualization?
More ladies.
There are more ladies? Okay. So when? Okay. So which of these graphs show that there's more? So anyway, so there's It's actually less ladies. So it turns out that it's actually, for this data set, is less women than men. So this data set behind this was like I want to say, well, let's say 4 million travelers, at least 4 million travelers, and about a quarter were ladies, and 3/4 were men. But the number of women is not shown here, right? So what's shown here, and it's probably not the best way to show it, is travel day is there, it's at the end, and that's prior to the days prior to traveling, right? And what that shows is that the women, on average, they book their flight. I mean, these are flights, they're taking a flight to go wherever they go for their destination. They tend to buy the ticket earlier by like, I don't know, 3 days. If you look at the top thing there is 3 days. That's one insight. So, okay, women buy earlier. It's true in travel. I don't know if it's true everywhere else, but for sure in travel they plan earlier. I mean, they plan better, more in advance. Another insight is, well, the older we get, so now you look at age of the traveler, it kind of goes down. The older we get, the more in advance we book, right? So we get better at planning. Long story short. Anyway, so those are two kinds of insights, which if I gave you 4 million tickets or 6 million tickets or 20 million tickets and kind of trying to figure that out from that, it would have been hard. I mean, you would have had to be really good to see those things within the data, but you have to have a way to kind of analyze and get that out from there. So that would be an insight. So an insight, so to summarize what an insight is, it's some non-trivial conclusion. Non-trivial, again, I'm not, I wouldn't defend that in a court of law, what my definition of non-trivial, but something that's not really intuitive, not immediately intuitive, that's derived from the analysis. Yeah? Make sense? So now we're getting into the mining. The reality today is that most insight comes by way of statistical analysis. Does that sentence tell you something? Does it talk to you? Do I need to explain that a bit? If you say nothing, I'll assume I need to explain. Okay. So yeah, the way it is, be it in science or wherever you are, those things where you just look at something and the data will just talk to you, those days are gone, right? You need to do something, some analysis. You cannot just count a few things. There you go, that's my insight, right? You need to do, I'm calling statistical analysis. It doesn't have to be a heavy analysis, but it has to be some sort of analysis. Otherwise, that insight, the low-hanging fruit wouldn't be there. It's true in science as well. There used to be a day when people were finding particles just by looking at the photography and seeing, this thing split into two things, therefore there's another particle coming out of it. That's no longer the case. So, for example, the famous Higgs boson discovery, this is the data, right? For the Higgs boson discovery, this is the data. Now, physicists were smart here, were clever, and they drew this to kind of influence your eye. But if you subtract that curve from there, it wasn't that clear that there was a signal in the thing. I could have said, well, maybe there's something here as well, and there's a little bump here. Why not something there, right? So again, you'll never pick up an event like you used to do back 50 years ago to say, here is my Higgs event, and this particle here flying here is this Higgs. Never. All you can say is, I was expecting 100, and I'm seeing 105. I have no idea which one of the 105 is the Higgs, but I'm seeing an excess within that thing. I should have had this, and I had a little bit more. And that's how it happens. So it's a statistical analysis. So the statement there is that there's a significant excess of Higgs boson. There's never, there's your Higgs. It's sad in a way, but okay, that's the world we live in today. You have to do a statistical analysis to find that insight, right? It's not going to present to you right away. Okay. So mining, data mining, by my kind of sort of definition is it goes like that. There's a starting phase, input, output, decision making. Okay, what am I going to use and for what purpose? Analysis, the real thing, and then the visuals. You need to make sense to really put that insight into a compact form, and that's where the visual comes in. And then there's a communication of whatever it is you have done. Just to know how I plan my time, because I kind of went crazy on slides, so I could kill you by PowerPoint. Like which ones of this would you be more interested in deep diving in? Just so I have an idea, when do I go fast and when do I? Analysis and visuals, okay. Anybody interested in the com side? Communication. So communication means you've got some insight, now what do you do with it? How do you share it? How do you use it to, because the reality is if you're in a business and you've done something great, there's an extra step required for people to know that you've done something great. And I call that the act of communication, right? The fact that from now on I need to make people interesting and people need to know what I'm doing. That's the communication of it, right? So it's the last part of the analysis, one that typically people like me, and I don't know what the makeup of the audience is, so if you're more kind of on the tech side, you see from the slides, I'm not the world's best communicator, but it's that you don't want to put in a lot of effort. You'd rather put in the effort into the analysis, insight, and understanding part, and then you're kind of like, well, let somebody else kind of deal with that. Nevertheless, I think there's some lessons there to learn as well, or at least there's things to be aware of. Yeah? Going once, twice? Okay, so we're going to the start. I don't know which one to use here. Let's try again. Start. Probably the most important thing. So if you're going to remember some the best choice of color here. Okay, so never mind. So what was my advice number one? My advice number one is have a clear image of what the output might look like. Okay, what does that mean? Well, it means, like I told you before, you're dealing with type 3 problems pretty much all the time. So before you start diving into an analysis, you have to understand, okay, what is expected from me? Or if it's so what is expected from you, or if it's not your CEO that asks you and you're curious by yourself, you still have to do that. You have the duty to go back and say, what does to have that thinking exercise to say, what's the output that I'm looking for? And write it down. I mean, really not just think you have it, write it down. Say, okay, if I had all the resources in the world, don't try to be, limit yourself to, okay, the data I have. But anyway, this makes no sense to think about it because I don't have the data. Don't worry about that. So this is the very start, right? You want to have a clear image of what you're after. Those guys at Higgs, that discovered Higgs, they had a clear picture. Okay, if we find that spark, this is going to be great. And we're going to do this, and we're going to do that, and it's going to be awesome. The guys that got Obama elected or Trump or whoever, the same thing. They have a clear picture of what success is and what they are after, right? The output is, okay, getting the votes for that guy, and specifically in that state, that state, that state. Obviously, Google has, again, it's clear they have a plan, otherwise they wouldn't be where they are. So, yeah, have a clear image and don't limit yourself. Don't start with the data. Yeah, go ahead.
Sorry, long question. So if you're dealing with a type 3 problem,
yes,
and the output is not clear,
correct.
right, but you clarify it to find some clear output, doesn't that give you a bias into seeing things which are not there just to enable you to find what you're looking for?
So, does it give you a bias? No, I think you're more biased to look, to think things if you start with the data more than with your computer closed. It gives you, so to me, when I say the output, figure out what the output is, it's both possibilities. Am I going to find the Higgs or not find the Higgs? On both of those, I figure out what they are. So I'm imagining a graph like this, so I'll tell you what exactly I mean by that. So in the case of Higgs, what I mean is I picture, people say picture the output. I'm picturing this, and I'm saying this is what I want. I would love to have this picture here, and you know what? If there's a Higgs, there's going to be a bump over here, what I think it is, right? But the output for me is this graph. This is the mass of the pair that I'm noticing, and this is the number of events, right? So the output is this. I am after this. I am after producing this graph, right? It doesn't mean that the graph is going to turn like I hope it's going to turn, but I'm hunting this. I'm hunting this thing with this graph. Same for the men and women. You picture that thing and you say, well, I'm going to look at the way they book. This is a distribution for men. Well, If it's for women, it's the same thing. Well, it's going to be something like that. But you know what? It might be like this, and it might be like that. And this is the thing that kind of gets me excited, because I'm saying, well, either way it turns out, okay, the boring thing is if nothing happens, then they're both the same. It happens. It happens. So there's behaviors for which men and women are completely the same. Okay, you lost the time, but you understood some things. On the other hand, if it turns one way or another, now you have a case. You have a case if you sell products in travel. You have a case of targeting, the way you're targeting, and all sorts of other things, right? So you have to keep that honesty and the door open that you might not find anything, right? And that's very important. So you might not find anything. Therefore, it's really important to work on questions that are really important, because that's your time there, right? So I would say, since you're at the beginning, don't work. I mean, if it's not really interesting to you, make it interesting to you. But yeah, so to come to that, so picture both cases. Either there's something here or there's nothing here, but it's very exciting. In fact, some people say they would have been much more exciting not to find the Higgs than find it, because then that would have meant something else is going on, and now we open a new book on what can possibly happen. The fact that we found it and we closed the book on the theory of the world is kind of sad. But yeah, okay, that's philosophical in nature. Did that answer your question? The bias question? I forgot to ask it. Yes? Yes? A little bit? Yeah. So I'll come back to the bias. I mean, it's true, there's bias. I mean, scientists are a bit more disciplined in the bias. I mean, everybody's biased one or another, but I think in science that happens a bit less. But I'll get to that when we progress a bit. Yeah. You have to keep that honesty and the possibility that something is not going to happen, and take pleasure in the quest. I mean, you might find or might not find an insight. The pleasure is the hunt, actually, more than that, right? It's kind of how it is. So something like the Higgs boson, the search for that was like 20 years. If people didn't take pleasure in the quest, there would be nobody looking for it after 20 years, right? So it's that sort of thing where if the question is really interesting, you wanna go after it. Okay. Any other questions so far? Yes? No? Okay. So that's kind of, again, there was the type 1, type 2, type 3 classification. That's the last, I promise, the last kind of framework structure that I'm giving you, so you don't burden your brain to too many things. But I think it's important when you think of an analysis to go back to this flow, right? So the analysis proceeds, in my mind, from objects to variables to values to distribution. Does it tell you something what I said here? So for example, let's since we've done the little thing, the men cover exercise here, why was I able to solve that, right? So what did I do? Well, I said, okay, manhole covers. I've seen those. So those are objects that so the problem is about estimating the number of manhole covers. All right, I've seen those in the past. So I was kind of familiar with the objects. I didn't say there's like 1,000, one every meter. I mean, I kind of had the feel for that. Not a good feel, because I said, okay, there's 10 in a kilometer. It might be wrong. Probably there's like 50 meters apart now that I'm thinking about. But still, I had a good feel about those objects. Then I said, okay, variables. Variables is, well, in this case, it's not really applying, because you asked me plain the number, right? You didn't say what area do they cover. You could have said, okay, what area is covered by manhole inclusion? And in that one, I would have said, okay, the variable that I'm talking about now, not just their number, I'm talking about their size. So therefore, I'm going to have to add the size. And, so the variable would have been the size, the value would have been, well, whatever the size in centimeters of manhole cover, and then the distribution of those sizes if there are different types of manhole covers, the little ones, the bigger ones, the much bigger ones, and so on. So the analysis proceeds like that. Objects, variables, values, and we're going to get the chance to try that out as we go. So remember that OVV, let's try to do that, OVVD, whatever, whatever, OVVD. All right, advice number 2, and probably another really important one, is understand the objects you're working with and their interaction. So I'm going to ask a different type 2 problem just to show you how that works. Let's say I want to estimate, since we're talking artificial neural networks, let's talk about, natural neural networks, how many neurons, nerve cells are in my brain. Let's try to estimate that. What type of problem is that? Type 2. Type 2. It's a type 2. So it's clear. The output is clear. I ask you for a number, the number of cells. There's no doubt about what I ask you, right? So I say, how many brain cells I have in my brain? Clear. But then I didn't give you anything. So, unclear input. So, go figure it out. So how do we estimate that? I need a volunteer. The number of neurons per cubic inch, okay? So inch cube, okay? How much is that? I could call my friend Google directly with a question, right? Directly with the how many cells are in my brain. Who has a different? So if you can ask Google just one question, but not that one, what would that be? What's the size of the neuron, right? So who asked that question, and why did you ask that question? Okay. So that was the thing. The object, so I'm coming back to my little formalism that I had here, which, the poor man's analysis guide, is the problem, the reason we hesitated on solving that initially was like, I'm not really familiar, I don't work with neurons every day, so I don't know those objects. You asked me a question about neurons, but the thing is I'm not touching those every day. So I need to get familiar with them. That's kind of when I said get familiar with their objects is, okay, get to know those things. Don't get drawn into working with some data about objects you don't understand. That's kind of, again, I've been burned like many times about that, kind of processing data, and you're always going to get the result. You're always going to have an algorithm, it's going to produce something, but if you don't understand what you're looking at, sooner or later, that thing is going to, blow up in your face. So, yes, so if I tell you, okay, a neuron is 1 micrometer, let's say that, 10⁻⁶ meters, then how do we estimate how many there are in our brains? So I gave you the size. Is that the volume of the brain? Okay, so the volume of the brain is, let's make something up. Again, type 2 problem. We were free to make something up. 2 liters. Why not? So let's say 2 liters. Okay, now you see the extent of my ignorance. 2 times 10 to a liter is a decimeter cube, 10⁻³ meter cube. Right? 1 decimeter cube. Okay. So then, we divide this 2. So this one we raise to so is the ratio of this to that. 2 times 10 to the -3 divided by 10 to the -18, I guess. And if it's a sphere, I'm going to have a little factor here in front. Right now, I'm assuming it's a cube like that. You see, it doesn't matter. So again, the point is type 2 problem doesn't matter. You assume it's a cube. And you end up with something like 10 to the 15. 10 to the 15, which means there's like in my brain, there's a million, what is that? A million billion, right? Is that many billions? Now, it turns out that this is, so a billion would be like a gigabyte for, everybody's a tech person, right? So a billion in the neuron is like a bit. It can be 0 or 1, right? So you're looking at this many things. It turns out that the real solution, that one I know, because I asked Google, it's 100, right? So, but still, we did good. We did good. So it's the real answer is 100 billion, which is let's say 10 gigabytes, right? So it's kind of scary, but what you can store in your brain, it's about 12 gigabyte kind of storage space. If you use all of that for storage, that's all you got in your brain. Anyway, point was objects, variables. So we said we need to get familiar with the neurons. We got their diameter, and then we did our calculation. We solved the problem. Okay. So moving on, input-output. Input-output, well, let's see what I have here, because since I have 100 slides, I confess I don't remember everything. So I have another, so now we're starting the real problem, the real problems. So again, I try to find something that would, don't shoot me for the answer, for the example, but okay, I thought of, okay, let's have 2 friends what in different cities. One of them gives a call to the other one and say, hey, you know, I just found somebody who's right for you. Come over here, you know, get on a flight, hop on a flight, and come over here. So now, if I am the person at the I'm married, by the way, but you know, let's assume for the sake of just the exercise of it. So let's run through the exercise. Let's assume that I can only ask very few questions about that person, right? Let's assume that I cannot, I don't know, for 30 seconds, whatever I can ask in 30 seconds, that's how the conversation goes. So what would you ask? And now this is a discussion about variables, right? So you'll see how it works in just a bit. So a volunteer to say, what would you ask somebody? Say, hey, I found the right soulmate for you, come over. And again, forget your for a second, just go with the experiment. The phone number. Okay, that's a good variable. Okay. What else? Actually, let's start a new one. Do we have enough? Yeah, sure. So phone number. What else in 30 seconds? I'm sorry? Facebook page. So why the Facebook page? Okay. So picture, I suppose, photo, likes, whatever she likes. That's exactly the scandal that got Facebook, crashing. The fact that through the Facebook profile, from 10 likes, they can put you in a very narrow category. Anyway. Okay, what else? So physical attributes, we got that with the Facebook. Yes? Sorry? Place. Place as in where she's based. Okay. See, address. Okay. All right. Address. I don't know if it's the French way or the... I don't remember. Okay. So you see, okay. So now if you had... So we asked for the Facebook, we asked for a phone number, for address. Now let's say you have a time for a nice conversation, but you don't have access to a picture. What else would you be asking for? Everybody would be single if you ask for that. Okay. All right, so, okay. That's not going the right way. This is an audience of developers. I shouldn't have known that. So we have height, weight. So this, some other people look for that. Okay, and if Alex is 40 and looking for a long-term relationship, older people kind of like me, they look for other things. If I were to look, okay, smart with the profession and so on. So you see, that's a notion of variable, right? So and this is exactly like the work you do every day. You work with things, with objects, which you don't see, right? Whether you're analyzing transactions, records, credit card records, I know what sectors you guys are in. You almost never see the person making the purchase, or you never see the objects involved in the actual transaction, whatever it is your company does, right? So in this case, it's the same. You're not seeing the person, so you're trying to get the representation of that person because you don't have access, and you do that through the variables. You try to say, well, is she beautiful? Is she this? Is she that? So yeah, you're in this is important, right? This is important. It's important to kind of understand. So if you are to take one lesson from this, is that be very careful for that bias, right? You never see the actual object you work with, and be aware of that. Don't dive and work with data unless you understand the objects, and don't forget the link between the objects and the actual data you're looking at, because that's kind of important. Then we can break down. Any questions so far? Does the notion of variable make sense? So remember, we had an object. We did not have access to it. An object, and again, object can be anything from transaction to the manhole cover to the neuron to whatever. And then we're trying to work to do something, because we cannot, when we're selling travel, I cannot go with everyone and see, did they have a good trip? Did the flight got delayed? Or, there's 5 million travelers traveling, taking so many trips a year. There's no way you can actually see what happens, right? But you try to do that through the data. You try to use the data to understand the insight, what it is that actually happened when the person was away, or what is the person happened when they purchased whatever you sold. Okay, so moving forward, yeah, we reduce the definition of objects for all purposes. When you talk about data mining, there's just a set of values assumed by a set of variables. So you decide, I'm interested in, let's say, address. Okay, well, the address is a variable, and then the actual value would be street whatever, da 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 da. Yeah, or is not a zip code, what's called a geolocation code or whatever. Right. So that's constitute your representation of the object. Is that clear? Yeah. Okay. So obviously choose your variable wisely. I mean, if you have 30 seconds or if you're limited somehow, don't ask for things that, don't just, make sure the variables you're asking for actually do make sense for you. I'll come back to this question because, to this thing because that's important. So let's push this one a bit further. And let's say I ask, or Alex, whoever was in that thing, he asked for the height. The first question that came to his mind, okay, how tall is the person? All right, so let's say the answer was 167. Then what? Then what? What type of question is that? What kind of problem is this then what? Type? Type 3. So this, then what? So I ask a broad question, but why did he do it? What's it going to do with that information, right? What happens? So let's pursue, we saw the variable, now let's see what happens with the value of the, once we gave the value of the variable, what happens? Then what? So by the way, why did he do it? Why do we think he did that? To compare with his own height, yes. So again, it's beware of the bias by asking for a variable and kind of trying to imagine something. In the world of one dimension, height, 167 is okay. That's not really 167, but it's something like that, right? So okay, you have no other information. It's like the light is turned off, and you see just the top of something. It means nothing, absolutely nothing, right? So be very careful not picturing somebody who you know that's 167. Oh, it's going to be that person. Well, all you ask for is the height, right? So why did he do it? I'm coming to that question. So, well, he did that because maybe he noticed a correlation between somebody being his soulmate or soulmate is the height, right? The taller, the better, maybe, but then he didn't want the person to be too tall because then he'd be like, so if this is his height, maybe he wanted something in between that, his height plus minus 20 centimeters. And why? Okay, why? Because, okay, so anyway, why doesn't matter. The point was that he asked for that variable. Okay, we're good. All right, so yeah, so that's how it works. So what I guess the message here is the bias. Don't mistake the value or the representation for the object, right? Unless different objects in different contexts can mean different things. Okay, so then, the little lesson here from that little starting exercise was, before you begin data mining, ask yourself, okay, what's the situation about? Am I familiar with that? If not, go and find information to actually find it, right? But don't look at the information first and limit your reasoning to that data that you have. Then take time to think about the object. Always spend time to think about the object. So there's probably the best advice I can give you doing data mining: close your computer and just think. I mean, that's by far. It sounds silly, and it takes practice to resist the urge to just dive into and do something with the data. But just close it and say, what am I after, right? So think of the objects, not about just the representation, the actual object, and then the output. What it is that you want in the limit of unlimited resources, budget, people. You had all of that at your disposal. What would you like? So remember, the Higgs people, they wanted to draw that and see, okay, is it going to be a bump or not? But they wanted to be able to draw that thing. So for that, they spend 10 billion. They build an accelerator, and just to be able to do that. Okay, I think I beat this one to death. It's everyone okay so far? All right. This one I'm hesitating. You tell me if it's getting too theoretical. So scale impact. So scale impact, I still think it's important, even if we don't necessarily understand no, let's try. So basically, how many variables can you use? Like when you get somebody on the phone, like how many variables are you going to ask for? That's a little bit the question. So let's assume there's only one variable, height, because we dealt with that, right? So we dealt with that. So we're going to have, and let's assume height is between, I don't know, 150 and whatever. You divide that into 10 intervals, right? And then what you're doing and what the person is doing, he's comparing the person we're talking about to what he has in his head about those the people with those height, right? So he's seen tall people, therefore it must be like that, or he's seen a little less tall people, it must be like that, or like that, or like that, or like that, right? So that's basically a comparison scale to say, do I have somebody in my brain store who's, for example, I cannot even imagine somebody who's 3 meters because I have nobody in my brain who's 3 meters, right? But I've seen a lot of people and I know different heights when I see them, right? That's kind of how the brain works. So you're comparing each object with something you have stored in your brain. So then, to be able to do that height assessment, we need a population. Let's say we need about a population of 10 objects in your brain for each interval. And if you divide it in 10, we need 100 people just to populate the height spectrum. Do I know 100 women or 100 men? Yeah, I do. So it's an easy one. It's an easy one to figure out. But still, you need 100 objects to do that. The problem starts getting complex when you take that to the next dimension. So if now we have 2 dimensions, I'll tell you in just a bit what this is. You're going to need 100 for this dimension, 100 for this dimension, which means you're going to need 100 squared. Another dimension, you're going to need 100 to the third, and so on. So in the n variable case, if we have n variables, we're going to have 100 to the n objects in our brains to actually be able to make that decision, do I like that person or not, based on that representation. Which starts getting tricky, because in my head, I probably don't have any more than 1,000 people stored. Let's say 10,000, because I watch a lot of movies, but that's it, right? That's how much I manage to store, right? So you see now the problem of asking for more variables and having a really multivariate analysis is that very soon you're going to run out of slices to put the people, right? Is this notion clear, what I'm saying now? So for example, a 2-dimensional analysis would be, I have a dimension, let's say this is height, this is weight, whatever, and each of them has 10 things, and in each of these, squares, I need 10 people. So it's 10 by 10 by 10, that starts getting really big. So anyway, if your company's data, what I'm driving with that is the number of variables in your analysis determined by the number of objects you work with in your company, right? Okay, now we're talking about not in your head, not about that example, but if you work in your sample with, let's say you're not, Google has a lot of data, but let's say you're a company that has 10 to the 7, 8, 9, so 1 billion things, 1 billion transactions. Okay, that's a very respectable company. Somebody who has 1 billion transactions, that's a very respectable thing. The number of variables they can look for is, if the variables are continuous, they're actually 5, something around 5. If the variables are binary, then you get a break here. Binary means yes or no, and they would be more like 2 by 2, right? 2 by 2 by 2 by 2 by 2, and that you arrive, if you have 1 billion things, you can arrive to something like 7 variables to use, right? So that's kind of the limit. The limit on the number of variables you're going to use in your analysis is determined by the number of objects or transactions or whatever you process. Does it make sense? And if you don't have enough of those, if you sell 10 breads a day, you cannot have an analysis that takes into account the softness of the bread and the this of the this and the this of the that, because you only sell 10 breads a day and you run out of breads. There's not going to be any bread that has the softness and the color and the crispiness and the whatever. So, yeah, okay. Make sense? So the lesson here, I guess, is beware, and I've seen it, and you've probably seen it, be very mindful of somebody showing you a 50 variable analysis. You're going to have people that claim, oh, I've done a 10, 20, 30 variable analysis. All right, well, you cannot really do that, right? If you don't have enough, unless you're Google, and not even Google can do a 30 variable analysis for one particular problem. Okay. So you want to code then a number, but that number would be the limit, the 180. Okay. Okay. That makes sense. So with the distribution, you catch both that and you catch the average as well. What other cases? What other cases? Well, for example, if you have 2 very different populations, right? You have somebody who, we're talking about the average spend in our companies, I don't know, let's say 300 per transaction. But in fact, it turns out that we have 2 products. One is, I don't know, 30, and the other one is, I don't know, 500. Right? So in that case, it doesn't make sense to talk about 300 because you have to look carefully at the 2 things you have. So segment is kind of a segmentation problem, right? It doesn't. You're going to do something different for this and for that, right? You're going to control them in a different way, and so on. So the answer, yeah, that's so there's cases in which the average is not enough. That's what I wanted to drive. There's no such thing, when we say, oh, the average person spends this much on their holiday, that doesn't exist. The average person does not exist. Just yeah, there's all sorts of jokes about the average person, but yeah, that's the average person does not exist. Let's leave it there, leave it at that. So then, how do we go beyond the summing and count, beyond the average, right? So the histogram, and now I'm going to say this is by far, for at least if I learn anything, is that the histogram is the most useful tool in data science by far. There's histogram is like this, and the next thing is very, very far down. So for that reason, I think it's important to talk about the histograms a bit. Does that talk to you, the fact that the histogram surprises you, or it was kind of logical? Makes sense. So I'll convince you it makes sense, because something I encounter in business is that people are unclear about what the histogram is. So let's just make sure we, following this workshop, we know what the histogram is, at least in the definition I'm giving here. So a histogram is basically an object defined by 3 numbers. The maximum, the minimum, and then the number of buckets or intervals in between. And we call those interval bins. So what you're doing then, you're reducing your data, however many data you have, all of us in the room, to the number of bins, to the content of each bin. So it's a convenient way for a data scientist or a data miner to reduce dealing with a lot of variables, but not give the average, which is just one number, right? So it's kind of in between. You're still giving something that a CEO could look at. So for example, is this one a histogram? Let's do a little quiz. There's prizes at the end. So by the way, this I just took randomly from Google today, so I don't know if it's copyrighted or not, so don't tweet that anywhere, because I just got them very quick. So is this a histogram? Yes. Who's got the no? We got no. It is a histogram? All right. So according to that thing, so do we have a max and a min? We kind of have, we have the thing divided, so it's kind of is borderline histogram. It's borderline histogram. Why is it not a histogram? This thing over here, it has to be continuous, right? It has to be time, right? Right now, this one stops. So this I call a bar chart. It stops over here. There's nothing. This thing here means nothing. Neither that this one means, neither the fact that these things, two things are together means nothing, right? So it's impossible to get from this the distribution. Remember, a histogram is a way to reduce, to capture the distribution of a variable. So the real distribution, what we call the mother distribution of that variable, maybe it was like this, right? What we're trying here, well, a histogram is an imperfect way because we never have an infinity of things, so we're trying to kind of go like this. So what's special about the histogram is that this is the variable, and this is some sort of count. So this is nothing. This is an axis, there's nothing, just number of objects, right? So a histogram, in a way, has only one axis, which is a variable, and then you count things over there. And these things, they have to, I don't like when people kind of draw this. There's no, in life, the real distribution, there's no lines, right? So you're trying to approximate the real thing. If you had, a million things, you would have done it right. So in this case, this one doesn't, I cannot tell what the mother distribution is from this. So again, I said this borderline, so you have to give me a little bit, and then so it's not, so okay. So you have to figure out, when you look at the histogram, you have to think, what's the mother distribution? Do I see the trend? Do I see what was behind that? Remember, we're working with imperfect things, but you have to see beyond that. And I'm not seeing, from this graph, I'm not immediately seeing beyond that. After that, that's a continuous variable. So I'm typically using histograms for continuous things. Time is continuous, but here it's kind of aggregating bins of 10, makes it a bit hard to see, but okay. It's a semi-histogram. I'm not satisfied with it just by the fact that I cannot see the distribution that was behind it, right, instantly. Let's do another one. Is this one a histogram? No, this one is much less of a histogram than the previous one. So if the other one I was willing to cut some slack, this one it's zero histogram. There's zero resemblance. So why is it a zero resemblance? It's got no, remember what's a histogram? It's got one variable and then there's a number of objects piled up. This one, it doesn't show me the number of objects, right? It just gives me something else. So there's kind of like a bar chart or something. Isn't it? I'm sorry? A monthly unemployment? No, so it's not yeah. So see, histogram, you have to say, for example, histogram would be if I have this month by month, and that's important, and then the number of unemployed people, however it varies, something like that. But even that versus time, okay, versus time, I have a bit of an issue versus time. Time is continuous, but then we count figures within a bin. Here, if we have an unemployment rate, I don't know how they calculated that. Maybe it's related to the number of people, maybe they divided that by something else, but it's a different thing. The same thing, if this was revenue, if they showed the revenue between this and that or whatever, again, I would have been a bit, right? So remember, you have to have number of objects or some measure of that. You have to really see immediately the link between the two. So, okay, let's call it a quarter, not a semi-histogram, a quarter histogram. Okay, finally a histogram. Again, I don't like the fact that those things are separated. But okay, that's arrival per minute. I don't even know what that is. But again, I have the time as you know, here. And then I have a frequency there. I think that's a histogram, whatever. Make sense? All right. So let's do some more histograms because so interesting. So that's one of the last exercises about the analysis. I'll make it the last one. This is tiring. So let's say the CEO asks you, what's the IQ of our employees? It's a silly question. I made it up. I mean, it's sometimes asked in real situation, you know, business schools, they look at GMAT, they look at standardized scores everywhere, you know, or, you know, universities to SATs, but okay, so it's kind of, it's not IQ, it's some sort of standardized measure of measuring somebody's capacity to think and do things. So what kind of, so if the CEO asks you that question, I just chose IQ because it was easier. What kind of problem it is, I gave the answer into the question, it's a type 3 problem. So how do we solve that? So we solve that, okay, you take a sample of 10 employees, you look at the numbers, and say, I'm going to build a histogram out of it. So it's clear, you know, when I look at these numbers, I scan them quickly, I'm saying, well, I need a 90, 130 as a max. How many bins do you want to do for this one? What's the bin size? 4? I'll, from 10 to 10, I'll double that. Anybody other binning for this thing? So I've done one from 5 to 5, I guess, and then we'll go from 10 to 10. So this is what the thing looks on a 5 to 5 binning. The 10 entries, and this is a histogram, so this is the IQ, and that's the number of people. Obviously, never, you know, that's another thing I don't like in histograms, always label the axis, which I forgot in the first instance. So IQ, number of employees. Now it's a histogram, right? So now, okay, you look at this histogram. Do you see the mother distribution? Well, maybe. It's not very clear, right? We have very few things. So for 8 bins, I'm not seeing it. I'm going lower in bins. Do I see it with 4 bins? Well, okay. Maybe it's something that kind of goes up and then it goes down. Why not? At the other end of the spectrum, if I'm now to double the number of bins, what's going to happen? So when I group more bins together, obviously the bins get higher and it gets more bunched up together. When I put a lot of bins, I'm losing some information. It looks like this. It looks really jagged. I don't have anybody who's 100, you know, 18 or whatever. So you're in the limit of very fine binning. All the entries would be 1, 1, 1, 1, 1, 1, 1, 1, 1, which is not a useful histogram. It is useful, however, the 16 bins, when you have a lot of, let's say your company has 17,000 people, now it becomes useful, right? So 17,000 people on a binning of 16 bins, why not? I'm seeing a bit the distribution behind, right? I'm seeing a sort of shape there. Okay, it goes up, it goes down, it's got a mean, it's got, okay, it's good. All right. So what I was trying to say here, so number one, the most important thing was to know that that's a histogram, because you're going to have to look at variables one by one, and you have to build a histogram for each of them, and you're going to have to choose the binning and see that it makes sense. I mean, if you're going to do data mining, you're going to have to do that. And then, so choosing n bins is it's kind of where art meets science. I mean, there's not a good rule other than make sure there's not a lot of empty bins. And then it depends on the population you have. The more population you have, the more you're able to draw it finely, right? 1 million people, I can draw a very nice curve, and I'm getting close to the truth. If I have only 10, it's a trade-off. So yeah, rule of thumb for the area you're interested in, what I call the relevant bin, kind of the middle of this distribution here, make sure you have at least 7 to 10 entries per bin. That would be my rule of thumb. If you're going to work with histogram, if you're going to do data mining yourself, you're going to have to build a histogram for a thing. Make sure in the area you're interested. It's okay. If in the tail you have 1 or 2 here, so be it. I mean, it's fine. You can even cut it and say, you know what, under this I have this many, over that I have that many. That's okay. Any questions so far? Surprised you that histogram is so again, the histogram is the most useful thing, because you're going to have to deal with the distribution of variables. There's no shortcut for that. You will have to, if you work with data and you want to go beyond the average, you will have to draw those histograms. That's your first entry into the analysis. Okay, so now the solution explained on a philosophical level. So what did we do by making that plot? So the initial sample had 17,000 IQ values. I cannot go to my CEO and say, oh, here is your answer. You asked for IQ, there's your Excel file. What's he going to do with that? Nothing. So I replaced that by giving him this graph, and what did I do? So this graph is 16 bins, so 16 numbers in essence, but in kind of a nice visual way. And I gave him, as well, or her, an average and the measure of the standard deviation. So I told him on average is 100, and then the standard deviation is about that. Now that's good information. I feel good. I transformed those 17,000 things into 18. 18, he can take 18. And plus is the visual thing, the picture thing, which makes it easy to bear, right? And that's why it's useful. So, you know, Excel, it's a big thing. Excel doesn't do histograms well. And that's kind of where the tragedy comes when you try to do data mining. If you're used to Excel, you kind of get stuck there. I forgot to ask, most of you use Excel for data analysis or other things? Who uses R? Who uses Excel? Let's do it. I use Excel a lot, so okay. And otherwise, if you don't use Excel, what do you use? Python? Not Python. Okay. Pandas. Okay. So they do histograms. Obviously, they do histograms well. Okay. Okay. So histograms are useful for sharing information about objects. They reduce the quantity of data we carry around, we move around, and choosing the right bins takes some practice. I will skip in the interest of time. Maybe go to visualization. It's a discussion about cubes. Anybody working with cubes? If you don't work with cubes every day, I will skip this one. So who's dealing with cubes every day? One person? 2 people? I'm inclined to, are you okay if we skip the cube discussion? Okay. All that to say, it was a long discussion to say that the cube is nothing but a histogram, right? It's aggregated data along certain axes. So I would have convinced you guys that that is true, but that's okay. To the analysis, we skip this one as well. Let's go directly into data visualization. I mean, I want to leave a bit of time at the end to make sure we have time. I mean, you might have other questions of things you've seen, you're worried, you're thinking, and it's a good time because we're together to give you the time to ask the question. All right, so data visualization. So I'll use an example again. So we jumped to drill 6. We accelerated a bit the pace to the soulmate thing. So we're going to look at a few visuals and try to understand what's a good visual and when it's a visual good and so on. So, okay, what women want, it's, again, how old is the perfume? It's an example I saw in a talk, and it was kind of very, and, you know, it's men and women. I'm going to treat both of them there. I just started with Mel Gibson, the previous one, because I didn't have a better picture. So how old is the perfect man? Again, it's a very open question, but there's this site that is called OkCupid. I don't work for them, but I found them in terms of data analysis very good. So basically what they do, they look at, it's a dating site, so it's like I'm sure there's many dating sites. So they look at the preference of people. When do people click on something? You know, what do people like? When do people click, and so on. And they have many ways of getting that information from people, what they're attracted to, and so on. So they did that exercise. And okay, the answer to that, it's in a book called Dataclism, written by one of the co-founders of OkCupid, and this is what the answer looks like. And again, the point of that was just to scare you to say, okay, there's a bunch of numbers, never carry a bunch of numbers on. If you carry more than 5 numbers, nobody understands anything. Although this one, if you look at it, it's a bit easier. So basically, if you look at this, so again, what are we asking here? We're asking how old is the perfect man? We're asking based on the woman age. So we're asking women, and we're saying based on their preference. So, you know, it depends on who you ask. A woman who's 20 says, oh, I'd like somebody who's 23 on average, and a woman who's 45, oh, that gets all the way to 40, right? And what that looks like, so what I like in this book, he makes a lot of visuals which are kind of nice. He finds a way to convey the data which is smart and doesn't require a lot of thinking. So basically what he did here, he said, well, there's a woman age versus the men who look best to her. So a woman who's 20, there's a 20 and 23. So it kind of starts high. When they go to about 30, it's kind of equalize. And then the older you get, you kind of like, you know, men a bit younger, whatever. That's on the dating side. That's their data, right? So apparently they have data for this kind of thing. Now, they did the same thing for men, and this is where things get interesting. So what's that going to look like? Who wants to guess this one? It's a flat? It's a flat? It's a straight line? Well, all right. It is a straight line. So, yeah. So 20, yeah, by the time a woman is, you know, old enough to drink legally in the US, you're past their prime. Anyway, so yeah, whatever. So I forgot to change the title. The title would have been What Men Want. Obviously, I was a bit. Anyway, so the point is, anyway, this is irrelevant. So I like the way he found, you know, instead of carrying those numbers, you know, he found a way to convey that information kind of a shocking, and that's a good plot, a good visual, right? Somebody that conveys information kind of, you know, boom, it hits you in the... It's not hard to get. It's like, oh, you need 10 seconds, and you go like, okay, I got it. There was no special effects or anything like that, right? There's another one in the book. I mean, he has many. The whole book is interesting. There's another one who has, you know, that's a histogram here. So he said, okay, this is how the two sexes rate each other, right? So again, a large number of male people, they rate women they see on the platform and the other way around. So what you see here, and again, without much insight any more than that, is, okay, you see that men is rated by women. So this is women rating right here. They're a bit more stingy when it comes to rating, right? So they don't just hand out a big score, right? Whereas male, you know, it's kind of like, it's a bit of a wider distribution. So again, it says something about the level of, I don't know, how stringent some requirements are when it comes to men and women, which I kind of find interesting as well, right? They caught, again, the insight is they caught an axis on which men and women behave differently. And that's an insight. For whatever reason, those are kind of interesting things. So it tells a story without even like, just look at it and you start thinking, well, yeah, it's kind of true because, you know, whatever. So, or you're thinking true or false, but it gets to think. And it's not like a big, you know. So I'll show you one or two more. So this is one that I thought it was one graph that was kind of successful for me. So I devised the method to measure travel stress. So when people travel, they get stressed. So I said, okay, what does it depend on? Does it depend on the gender? Does it depend on when you book your trip? I was trying to do the data mining to see what does stress depend on. And this is this is one of the dimensions, is the dependence of stress on the travel frequency. So I mean, when really you have really bad trips, it's almost really bad trips, they don't happen. You know, it kind of stabilizes when you go to the far 30 trips per year. You have people who travel 30 trips a year, kind of levels up a bit. I mean, the trips are shorter. You're much more used to things. You get better. I remember, when I presented this, there was a huge discussion that started. There were people to say, travel managers and stuff. They're saying, well, let's control more on that side because those areas is stress. There are some that were saying, let's make sure, we don't have somebody dying on a trip of stress, stuff like that. So it generated discussion again. It was a good graph because it generated that discussion, right? So people made whatever they wanted out of that, but it made them think, right? Just like the men and women, it makes you think. You look at it, okay, and then you start thinking about what it means. Another one, and again, to convey a point, another one from travel was, you were trying to look at, so there's a concept in travel called bleisure, and bleisure is mixing business with pleasure, meaning that, I'm coming for a business trip in Cluj, and then I'm staying the weekend. That's a bleisure trip because I'm staying, for pleasure the 2 days, right? So there's a whole hype about, okay, how do we cater to business travel to make bleisure easier? Maybe we let them book an Airbnb through the same booking platform as the corporate and so on. So, okay, anyway, a study of that showed here that, okay, people tend to bleisure the farther, I mean, it's kind of normal, but what this shows that the more the business trip distance, the farther you travel, the more likely you are to stay the weekend. To the point that if you go, New York to Miami is 15%, London to Miami is, more than 25%, and Singapore to San Francisco is just like 1/3 of the trips people stay there. I mean, it makes sense. It makes sense for many reasons. It makes sense they did the whole way. Why not take the weekend, relax, and do something there? Anyway, so again, it conveys the point that it grows with distance. The probability to do bleisure, it grows with distance, and it gives you an idea that, okay, it can be pretty high for certain destinations where people travel. It can be pretty high. So to come back and kind of summarize that, I'd say, what do great visualization have in them? I mean, those are good visualizations, but in general, what's a good visual? When's the visual good? I think the question has to be interesting, and I don't know that I come back off, enough to this idea. Work on an interesting question. When you're going to do something, if you're going to do mining, mine for an interesting topic. Even if the result doesn't come out as you hope it's going to be, just use your time, because you might find nothing, and at least you need to take pleasure in the quest to find it. An interesting question, I mean, if you do find something, that makes for a great story, like the OK Cupid, they ask the right question, right? Then they're simple. They're simple. If possible, one idea only. So there, I remember when I showed the plot with men and women, I confused you with that. And that was not good. That was not a good chart, by the way. That was not a good chart. So I confused you because you've seen there two things. I was talking about age, and I was talking about men and women. So there already I was trying to convey two things. That's not a good practice. Not a good practice. So that immediately got you confused. What is this guy doing? Okay, there's a longer thing for women, therefore it's more of them, whatever. So you lost interest into trying to put everything back together, right? Because it was more than one thing that I tried to convey. So if possible, try to convey one thing. With the gray visual, try to convey one thing. You have a unique data set behind. All those things that I showed before, they were good because the data set were kind of not something usual, not something, the dating thing, that's kind of, who has the dating set? There's a few sites that have that and a few sites. We don't see them all the time. They relate to the viewer on a personal level. That's a bonus. I mean, if you manage to do that, that's, to talk about things people doing, they can relate to, that's good. If I talk about price of a transaction, if I tell the average ticket price is this, on Singapore, I don't know, New York is that, or here is how it varies during the year, okay, it's interesting, but so what, right? You're not personally connected to that. Use the right type of chart. The right type of chart, histograms, scatter plots, 2D histogram, you're starting already to get into, if you're targeting a broad audience, you're starting to lose people, right? So any more than two things, two axes, confuses people more than it helps them. So try to use the right type of chart. We're not getting into that. There's a bit of a science, but the good news is there are not that many, right? So histogram, scatter plot, and a couple other things. So anyway. And then do not confuse us, stick to the convention. So you saw, again, I'm coming back to the example that I gave and did not go through. The date of travel was here. Normally, we're used to see the time running like that, but I was running like that, days in advance I'm booking. So I say 20 days in advance, 30 days in advance. That goes counterintuitively, right? If something grows that way, instantly you go like, whoa, you blocked. So what is that thing and where's it running back? I mean, your brain doesn't immediately, so don't, I mean, if there's some conventions, try to stick to them. If you know, green is good, red is bad, you know, I chose red and I got bitten by that. So going up is good, going down is not so good, right? So it's try to not surprise people on purpose with things like that, right? If you can correct that, live with it. And then the last one, I'd say you should teach more. I mean, make people think that entertain them visually. Entertain them visually, everybody has seen those plots where there's like, or a network graph that connects some cluster here, some cluster here, some cluster, and they're all connected and talking to each other, and you can tell all sorts of things from that. It looks cool, but you're not getting anything out of it. You're pleased visually because there's so many things on the chart, but you're not instantly getting what it's about. So if you get the chance, try to be more on the teaching side and more on the entertainment side, if you can help it. And this concludes the visualization stuff I have. We'll talk about the communication a little bit. We're almost at the end. Stay with me. So you can use data mining to market your product. And there's people who do it very, very well. There's people who do it less well. But pretty much, it's my conviction that anybody can do it. We're not doing it enough at Boosters. We're starting to do it. But anybody can do it. You don't have to work at Google. You don't have to work at Facebook to actually tell a story with data, right? I don't know if I convince you about that. So the idea is build awareness about your product. Maybe you're not selling. You know, using the data and using the visuals and using the insights, you're conveying, you're telling people you have that. Like the person that was telling us about, you know, the what women like, what men want. They didn't sell my product with that thing, but I'm aware of that. I know about OkCupid, and because I know it about them, you know about them, right? So that's kind of where you generate a buzz, and yes, in that case, it was a buzz because you're building that data analysis that interests people. Some examples I have, just like in the case of the charts. So I'm starting again with this. I mean, they have many early on when this guy was the Dataclysm author. When he was at OkCupid, he maintained a blog. It still exists, the blog, but now it's more like dumbed down a bit, or you know, it's more quick, succinct, and less shocking than before. I mean, maybe a function of maybe most of the insights were drawn already, and there's simply not more. For example, this must have received, I'm sure, like hundreds of millions. I mean, if they would measure that, this is one of them. You know, it's called "Don't Be Ugly by Accident." So they talk about the profile picture that you put on your OkCupid, and they've done a study as to what's successful. When do they get clicks? With what kind of camera you're taking? At what kind of time of day? Are you more smiling? Are you more doing this? Are you covering your face? Are you not covering your face? All of that is explained in the blog, right? And they tell you how to do it, right? So, and they do that based on 11 million profile picture and the number of hits they get and so on, and they try to find things that are similar, and that's a very interesting. This is a very interesting read. Whatever, it's an interesting read. And they do it well, and not just with that, they have many, I would say, many stories. Something, Freakonomics, does it tell you anything? Freakonomics, have you heard of it? The books, the Freakonomic books? So basically, Freakonomics books are two economists, or one economist and one social scientist. They had a series of very successful books. The first one was called Freakonomics, and then they just changed the titles a bit, like Super Freakonomics or something else. And now they have a blog and the site and the whole business around it. But it was very kind of successful because it told stories about unfamiliar topics. So for example, you know, they have a whole chapter in the original book about drug dealing in Chicago. This is very interesting. I mean, for me, I never dealt drugs. So it's kind of interesting to see how the economy of drug dealing works. Now with the movies like Narcos and stuff, I mean, the series, you know a bit more about that world, but otherwise I wouldn't have known anything. Sumo wrestling, you know, what do sumo, you know, there's cheating in sumo. There's arranged matches in sumo, which is at a scale that's, you know, huge. And again, I knew nothing about sumo wrestling, and that people read that just because it exposed them to a world to which they had no connection before. And it's kind of interesting, and they found a way to quantify that world, which is interesting. And again, they have a blog, and you know, you can read that as well. Who else does it well? Nate Silver does it well. So if you know Nate Silver, who knows Nate Silver? Not so much. So Nate Silver is a prediction guru. So if you're talking prediction of presidential election, that was his job. He was the best person in the world to predict presidential elections. As in, for the last 6 elections, he predicted not just the right president, but all the states how they're going to vote. Until the last one, where he got it wrong. So, but okay, he got a lot of hit for getting it wrong. But the way he does it, he's assembling results from the polls. So they run polls in all the states, in everything. So, and he has a meta-analysis of all the polls and say, based on these polls, if these polls are correct, this is how the vote is going to go with this probability. So he had Hillary winning with like 70% or 66%, and then she lost. And people don't understand that 30% is a big probability that thing is not going to turn out, but they don't understand. People just expect, oh, because it was 70, must have been, that should have been the president, right? So I think he lost a bit of shine through that last election, that prediction, and the polls were not really done well, but okay. So, okay, and you see 2018 election, 320 articles about that. So what he's doing here, he works on, he's talking about something that that interests people and in real time. So he's doing it. If he does it like 6 months after the election, forget it, nobody's going to read that. So he does it. That's a real-time element that makes people, it's the context. People are interested about the context. They're interested to know how it goes, and they go to the blog. 538, it's called 538, the blog, in case you want to check it out. And 538, I think, is the number of people in the House of Representatives in the US. So data marketing, another one, it's flights. Again, this is entertainment in real time. The other one is more like useful. This one is just entertainment. You've seen this. They showed the flights. There are many sites that do that all over the world at any given time. So for example, this one was at 5:28 UTC. That was the status of the flights over Europe, and I could zoom in Romania and see how many flights are in the sky and where are they. It serves absolutely no purpose for me, but it kind of calms me down to see the things moving like that on the screen and knowing that, I don't know, it's entertainment. It's really entertainment, but the fact that it's real time, you kind of feel like you know something that otherwise you wouldn't. So they get a lot of hits with that. Let's see what else. Yeah, there's some, that's a big deal. So there's the guru of David McCandless is his name. So data visualization. So he's one of the 2 gurus of data visualization. So to communicate with the wide public, right? So once it's in the open, you have to talk to everyone. It's no longer to the specialists knowing how to look at the histogram. You're talking to everyone. So what McCandless is doing here, he's finding a way to convey a bunch of numbers in which everyone can kind of understand. So what he's saying here is, okay, the divorce bill for the UK, the Brexit, cost 40 billion pounds, where their UK current EU fee per year would have been like 8. So, they have a hit of 4, what is that? 8 times 5. 5 years worth of fees, they lose it right away by exiting right away. And then they put that in comparison with it's as much as their defense budget for a year and so on. It's kind of interesting. But again, this is one of the many, many, many hundreds. On the side, when I need inspiration, that's one of the places I turn to. Is there one more? Yeah. So that's a bit of a riskier one. So basically a riskier one when you do a thought-provoking thing, so you're twisting the reality to make a point. I don't even know what the point is here. So have you ever seen the deformed charts? Has anyone seen deformed charts before? So deformed charts we're used to seeing countries occupying the space related to their land. But if you try to convey something else, like the happiness, for example, the area and you say, I want to put the sum of the happiness, I want to make that to be the area of the country. Something like the US would get very small, people are less happy, and somebody like, I don't know, Bangladesh, which is not here, would get really big. Things like that. So they try to make you think, don't think that because the country is small, they're small in every other way, right? So they're deforming things. So for example, this one, I just clicked on the first thing I saw, is of whales and men. So, Japan is the last country where the whale hunting is legal, and this is kind of where they hunt the whales, something like that, right? All the other countries, they stop the practice and so on. So they try to convey the point that, okay, it's whatever. So it's whales killed between, and then you can deep dive and say how many whales were killed in the last 10 years versus the one before and so on. And they do this just to make you think, so it's thought-provoking. But you have to do well. If you thought-provoke something, it has to be obviously wrong. right? People cannot say, oh, he got it wrong because. So obviously, there's nothing right about, all South America being like that. So obviously, they did it on purpose, right? It wasn't like something that was kind of maintaining the shape and so on. But again, they get a lot of hits and they do a lot of, to the point they make a business out of that, visualizing different elements of what happens in the world. And I guess the last one I have, it's informative. This is more like, informative is giving data. For example, what this is the economic observator at MIT. So they basically have a lot of data about import-export in many countries. In this case, I picked Romania. I picked Romania here. You pick the year, so I think I picked 2016, and you can look at either import or export, and you see what Romania does. Kind of on an aggregated thing right away, and you can deep dive into this thing. You can double-click and say to whom they export and what. And this is, so for example, Romania exports more. I didn't think vehicle parts, cars, obviously, with Renault. I don't know if other ones are producing, but that's basically the export, and then you can do the same thing for import. And you can do it for every country, on every year, and so on. It's kind of interesting, but there's just information. It's making the information available to you on different topics. Make sense? So those are, again, I know about MIT, and MIT gets hits because they make this data available to people. I don't know if you have a data that's that useful, but if you do, making it public could be a win-win. And then the main takeaways for the session, I just randomly, I said a lot of things. I probably tried to convey too many things. But I would say if I'm to summarize, try to think without the data, right? Something we don't do well today, and we for sure, we tend to go to the Excel file, zoom in, grab the column, see what it is, do a pivot table and so on, which is not the right reflex, right? So the first reflex should be, okay, what am I trying to find and how and what's the output? Can I draw it? Can I draw what I'm after? And once you can draw it, that's like, that avoids a lot of wasted time. Then have a mental picture of the output. That mental picture of the output, you have to have it at all times. It might change as you go with your analysis, but at any given time, if I say, what are you trying to get? You have to be able to articulate, well, I want to get a plot that shows the number of user dropping by the time of day. I don't know, whatever. Time of day, this is hours, and number of users. I don't even know what that means, but okay. It has to be clear what it is you're trying to get, and keep that picture in your mind as you go and do things. Because otherwise you're going to get lost. That's why I say there, don't randomly slice and dice. Don't start with Excel and do things, because you will get lost. I guarantee you will get lost. You'll lose more time finding something interesting than otherwise. Then comes the statistics. I would say probably, if I look at the data mining process, and I try to divide into the value of it, I would say probably 70% is you thinking about it, just saying, what am I doing and how am I going to do it, more or less. So it's that time, the value. I'm not talking the time you put in, but just the value. The next thing, I would say the 20% would be the way you set up the experiment. It's like what am I going to measure? If I'm doing the manhole covers, how am I going to measure it? Okay, I'm going to talk to this. Just setting up that experiment, how am I going to do it? And then the tool itself, what am I going to put the data in, and is it going to be R, Excel, Python, whatever? It's less than 10%. All tools is just a commodity for, doing it. Today, tools are really commodities, right? So design statistical experiment, don't lose sight of uncertainties, be honest. So that goes to the bias, to the fact that if you think of the output, aren't you biased somehow? You are, but try to be honest, right? Try to maintain clear the possibility you're not going to find what you're looking for. I'm going, and be honest, just be honest. I'm going into many conferences and even data conferences, and people say, so you say, the average price on whatever is that, and they say, oh no, just the other day I found a ticket that was cheaper, or I know a person that did this. So they try to use that thing that because my grandfather smoked till he was 80, smoking must be good for you. So be honest, just so recognize that BS and call the people and say, okay, that's an exception. It's called a statistical fluctuation. Stay with the actual, sample, with a large enough sample, and stick to what that tells you more than, oh, I'm going to select a little slice and I'm going to talk about that. That's kind of dishonest. And then the last thing I would say, people are going to talk about the garbage in, garbage out, bad data, having bad data. So a lot of people confuse data and analysis, right? They would say, well, it's the data that's wrong. I think what's wrong in, I'd say 90% of the cases is the analysis, is the way that people thought through the analysis. Is not, a well thought through analysis, you would go and get the right data. And if it turns out to be wrong, you would tweak it and whatever. But the data itself, data is just data. It's not right or wrong. You're collecting something. If you're collecting the wrong thing, well, it's unusable, right? So try to think it's a more philosophical thing, but I don't think there's such thing as a bad data. Even if the data comes, flat or whatever, it's still the data is as it is, and the fact that I see that it comes out flat, maybe I didn't collect it right, and I changed something in the process to collect it and to actually start getting the real good data. Anyway, so I talked a lot. I'll stop here. I would turn it in for questions to you. I mean, I talked a lot about the things, but what would you, other questions? I mean, something that came to your mind as we were going. Yeah?
When you were talking about choosing the correct number of bits for histogram, do you use the elbow method, for example, or do you try different numbers of bits and see which gives you more, like a better result?
The question is twofold there. So I don't know if I'll answer that because you asked two questions. So one is what method do I use? And two, what do I do? So what I do, I typically, when I try to visualize things in the mining stage, I do it by eye. I'm doing, okay, it's not enough. I'm not seeing the distribution behind, so I'm changing it such that I see the distribution behind. Now, the reason you ask the question is, okay, which method do you use to bin? Is because there are some methods, and this I'm going a bit into the analytical depth, is the actual output of the analysis depends on the binning. So there's things in which, so in those cases, like let's say I do a KS test. Like, again, I'm a bit technical, but let's just say this is something that gives you a number. It's an algorithm that gives you a number. I would try to do it unbinned. If I really, I'm after a number, not after showing or understanding something, but I'm after an actual number that comes in through analysis, I would try to do unbinned analysis. So just use the variables as they come. So all the methods that you can go so fine until you're unbinned, basically, and I would go with that. But again, you cannot visualize it. An unbinned histogram is just a flat thing with ones everywhere. So maybe some ones here, a lot of ones here where there's a peak. So you cannot really look at that. You don't really see anything. Make sense? I use my eye. I mean, for anything that's visual and kind of trying to understand, I use my eye. For anything that's number-driven, I use that. One more question? Yes. There was one question, you said? One more. Okay. One more question. Okay.